So let us take another one example in moment distribution method, including the sway condition. So generally we already uh, knew about the different sway condition, that is due to the exertion of horizontal load or different column height or different material property, different support condition will lead to the sway condition. So in this problem, a horizontal load is applied at the joint B. So let us give the names A, B, C, D. And also the material property, that is moment of inertia, differs for the columns 2i and 1.5i. And also the length of the column is different, 6 meter and 4 meter. The beam length is 4 meter. So what are the overall steps for the analysis of sway frame? The overall general steps is first one, non-sway analysis. Non-sway analysis. That is, we have to analyze the frame not considering the sway condition. Second one, sway analysis. Third one, H calculation, that is horizontal reaction calculation. Horizontal reaction calculation in non-sway condition. Fourth one, H dash calculation, that is sway horizontal reaction in sway analysis. Then only we can find the correction factor. That is R, can be named as R, that is H dash, sorry, H by H dash. H by H dash. That is a horizontal reaction in non-sway analysis divided by horizontal reaction in sway analysis. Final step, the calculation of final moment equal to non-sway moment plus correction factor R into sway moment. So we have to remember these steps before starting the problem. And also we have to analyze when the problem is given whether the different support conditions, that is both the ends are fixed, means we can apply 4EI by L or I by L for the distribution factor calculation. Here both the ends are fixed. Next one, whether the loading is available in the span of the beam, because if you want to calculate fixed end moment, then the loading should be applied over the span. Here the loading is applied at the joints, so we can't calculate the fixed end moment. So there is no non-sway analysis for this frame. If the frame is applied at any span, we can calculate the fixed end moment WL square by 12 on the left support and minus WL square by 12 on the left support and plus WL square by 12 on the right support. Then only we can able to create the moment distribution table and we can analyze the problem to find the non-sway analysis. In this problem, there is no load on this any of the span. I am repeatedly telling the span should be loaded rather than the joint. So the joint should be, with this understanding, we can continue this problem. First of all, first of all, I can write first one, non-sway analysis. We just start non-sway analysis and try to find the fixed end moment, that is M bar AB, M bar BA, M bar BC, and M bar CD, and M bar DC, and M bar CB, all are 0, because For the column, there is no load. For the beam, there is no load. For the another column, there is no load. The load is acting on the joint. So we can't calculate the fixed moment, fixed end moment for the non-sway analysis because there is no formula for the fixed end moment calculation when the load is applied at the joint. When the load is on the span of the beam, then we can calculate as minus WL by 8 plus WL by 8 minus WAB square by L square plus WBA square by L square. So whenever the load is at the joint, we can't able to calculate the fixed end moment. So the non-sway analysis can be started only when the fixed end moment values are available. So in this problem, there is no need of non-sway analysis. We can directly go to the sway analysis. And another one thing, and the horizontal reaction in the non-sway analysis, if you note the exact loading 80 kilonewton, HA and HD, because the load is acting on the right side. So the reaction will be created towards the left side. So summation of HA plus HD, which is equal to H, which is equal to H, which is 80 kilonewton only, which is 80 kilonewton. So you have to analyze the direction of HA and HD. It is towards left because it should oppose the horizontal force. So it should be towards left. So opposing 80 kilonewton, HA and HD both towards left. So summation of HA and HD should be equal to the horizontal load H. So what is the horizontal load? Which is 80 kilonewton. So the net horizontal reaction should be equal to 80 kilonewton. And also keep the note of the direction of 80 kilonewton. The second one, we are coming to the distribution factor, because no need of calculating the distribution factor for the non-sway analysis. Then I am giving for the distribution factor analysis. How we can calculate? So joint, member, K value, summation of K, and distribution factor. So there are two internal joints, that is B. The members are BA, BC, and K is both the B2A as well as B2C are the rigid condition, that is fixed support. So we can write I by L. Here BA, I is 2 times of I divided by L is 6. Okay, B2C, I is only I divided by length is 4. Okay, and if you cancel, it is 3. So the summation of K is, if you take LCM, 3 4s are 12, and summing up the numerator, 3 plus 4 equal to 7. So 7I by 12. And if you calculate the distribution factor individually, that is I by 3 divided by 7I by 12, which is equal to 0.57, which is equal to 0.57. Here I by 4 divided by 7I by 12, which is equal to 0.43. So this is for joint B. I'm going to the next page, that is joint, member, K, summation of K, and distribution factor. Now I am taking the joint C. So C2B is available, C2D is available, and K is I by L because of the fixed condition from C2B as well as C2D. Both are fixed support. Internal joint is also considered rigid support. So C2B and C2D, both the ends are, the far end is fixed condition. So it is I by L. Here it is I. Here it is 1.5 I. So I by 4, the length is 4. Both the members are 4 meter length. Then 1.5 I by 4. I am taking common denominator as 4. So next one is the numerator is 2.5 I. Summing up of I plus 1.5 I equal to 2.5 I. And the individual distribution factor I by 4 divided by 2.5 I by 4. Here I by 1.5 I by 4 divided by 2.5 I by 4. So it will lead to the result of zero point 0.4 and 0.6. The summation of distribution factor at the joint should be equal to 1. So 0.4 plus 0.6 equal to 1. So we have completed the distribution factor. Next one, sway analysis. Sway analysis. The previous examples, or you might have referred some of the examples in your textbook. When both the column length are equal and subjected to varying span load, that is unsymmetrical load of some W kilonewton, the sway analysis can be done by assuming some arbitrary moment for A to B, B to A, and C to D, D to C. And we are going to include fixed end moment for MAB and MBA bar, MCD bar, and MDC bar. So we can assume minus 100 arbitrarily for all the values because of the equal height. Both the length of columns are equal. In the case of length of columns are equal, the sway will be in equal magnitude, that is delta. Here is also delta. The moment is also anti-clockwise in both the cases. If you note down the direction of moment, it is anti-clockwise. And the moment value when the joint is having delta deflection is 6 EI delta by L square. We already studied in slope deflection formula as well as the moment distribution support sinking problems. So the moment at M bar AB and M bar BA, M bar CD and M bar DC is minus 6 EI delta by L square when both the column lengths are equal. It is to be noted, kindly noted. When the column lengths are equal to L, we can assume equal value of minus 100, minus indicating the anti-clockwise rotation. So we can simply assume minus 100 and minus 100 when column lengths are equal. In our case, the column lengths are unsymmetrical. One length is 6 meter, another one column is having 4 meter. So we can't assume equal value of fixed end moment for the sway analysis. So for that, we can assume any one of the value minus 100. Let us assume MAB bar and MBA bar equal to minus 100, and we have to relatively calculate the value of MCD bar, MDC bar for this case. We have to assume any one value. It will not be equal for the other column because of the different length. Then we can calculate the next value of moment. How we can calculate? What is the value of AB bar and MBA bar equal to 6 EI delta by L square equal to minus 100. Here you can calculate. It is L1 square. We put it is L1 square because we have different length of column, no? So delta equal to, okay, otherwise we can simply relate the values. How we can relate? The MAB bar and MBA bar equal to minus 6 EI delta by L1 square equal to minus 100. where MCD bar equal to MDC bar equal to minus 6 EI delta by L2 square. Okay. If you divide this, uh, here it is, we can solve by some other method. If you divide both the equation, you can get the ratio of MAB bar divided by MDC bar or MDA bar divided by MCD bar equal to minus 6EI delta by the length, first member length is 6 square divided by minus 6EI delta by 4 square, the second column length. And also we have to note the value of I here. For the column number, we have to note the value of I. What is the I value for the first column? It is 2 times of I. Here it is 1.5 times of I. So we have to include that also. Minus 6E into 2I into delta by 6 square divided by minus 6E into 1.5I into delta by 4 square. So you can eliminate common terms and you keep this minus. You keep this minus throughout the process, and also I value and also delta. Now you reciprocate the expressions. 2 by 6 square into 4 square by 1.5 square. 2 by 6 square into 4 square by 1.5 square. This can simply multiply 2 into 4 square equal to 32 divided by 6 square into 1.5. 6 square into 1.5. It is only 1.5, no? It is only 1.5. So 6 square into 1.5, it is 54. 6 square into 1.5 is 54. So it is not finished yet. So we have written the equation MAB bar divided by MDC bar, which is equal to MDA bar divided by MCD bar, which is equal to minus 32 by minus 54. Minus 32 by minus 54. So we have to keep this sign in every step. You should not cancel the sign. So minus 32 by 54. So if you compare these values, you can take MAB, the fixed end moment value for MAB bar, MBA bar, which is equal to minus 32, and MDC bar and MCD bar equal to minus 54. So you take this fixed end moment value for the sway analysis. Okay, with this we are going in the right direction. So the next distribution table, moment distribution table, first one joint. I'm shortly writing number, distribution factor, and fixed end moment. So joint is A and B, C and D. So the member comprising of the joint B having two numbers. So we have to give more space for that. So I am approximately drawing the columns, member, distribution factor, and the fixed element. Okay. The member specification is AB. Here it is BA, BC, CB, CD, and DC. And you try to divide this also. Okay, distribution factor we know that is 0.57 for BA and 0.43 and zero point 0.4 and zero point 0.6. So this analysis is the sway analysis. Non-sway analysis is not there because of the load not presenting in the any of the span of the member. Next, fixed end moment value. What is the value? MAB and MBA is minus 32. So minus 32, minus 32, and also MDC bar, MCD bar is minus 54. So minus 54, minus 54. Now you try to balance the joint B and joint C. So minus 32, here you consider 0. So you have to balance B for plus 32 and C for plus 54. You just multiply the corresponding distribution factors and put it below. So plus 32 into zero point 0.7. So it is 18.24. Here it is 13.76 and plus 54 into zero point 0.4 is 21.6 and 32.4. So now the redistribution, that is carryover of moment, should be done. Both the ends are fixed from B to C. So the moment should be carried over to B to A as well as B to C, and the moment should be carried from C to B as well as C to D. So first half of the moment carry over to here as 16.2. Here it is 9.12, and from B to C and C to D, the carry over should be done 6.88 and 10.8. So with this, you just this is carry over over. Okay. So just draw a line. So this step includes a carry over. You just add minus 32 plus 9.12 as minus 22.88. Here minus 13.76, 24.56 and 28.48, minus 21.6, minus 37.8. So further consider the balancing. So this is bending moment trial 1. You can keep bending moment trial 1. And further you balance B as minus 13.76 plus 24.56. So you have to consider minus 10.8 for the balancing. For the C, you consider minus 6.88. Again, you multiply corresponding the distribution factor and put here minus 6.156 and minus 4.644, minus 2.752, minus 4.128, and the half distribution should be done, that is minus 2.064 here, minus 3.078, and inner carry over of minus 2.322 and minus 1.376. So now you add these three rows to find the next level of moment values. So this is bending moment of trial 2. You add this minus 22.88 minus 3.078, that is minus 25.958, minus 19.916 and plus 18.54 and 23.406 and minus 25.728 minus 39.864. Again consider the balancing steps for the joint B, that is plus 1.376, and C it is 2.322, and you multiply with this corresponding distribution factor here 0.784 0.59, 0.93, 1.39, and carry over to the nearest joint 0.695. Here it is 0.392, and inner carry over 0.295 and 0.465. So you consider these three steps to add the next level of values, bending moment values. So next one is bending moment values of third iteration, minus 25.566, minus 19.132, plus 19.595, and 24.631, minus 24.34, minus 39.169. Okay, this is more or less it approaches towards the uh, last iteration. So we can consider minus 19 plus 24 minus 24 minus 39 and minus 25 for the next level of calculation. So first for the non-sway analysis, we know 80 kilonewton is the H value, is the net horizontal reaction. For the sway analysis, we have to find the H dash calculation, that is net horizontal direction reaction for the sway analysis. So consider only the column member because column only subjected to the sway condition. So A, B and D, C, and the values are, the moment values are minus 25.566 MAB and minus 19.132 MPA and minus 24.34 MCD and minus 39.169 MDC. So these values are we got from sway analysis. So you mark the direction. You have to look when the frame member is considered. You have to look in this direction for the direction for the moment direction of moment marking. You have to look in this manner. So if you look from this side, you mark this anti-clockwise. Okay, from B to A is also anti-clockwise. And you can assume the direction of reaction when this type of moment is acting, that is both the moments are anti-clockwise. This moment will try to push this frame towards this direction, and this moment will try to push towards the downward direction. So according to the direction, the reaction will be acting like this. If there is no load in the column member, then only this type of assumption can be made. If there is a horizontal load in the column member, the direction can be varied according to the applied load. So when there is no load and both the moments are anti-clockwise, you can assume the direction like this. Towards the moment direction, you can mark the reaction direction. Towards the moment direction, you can mark the reaction direction. Okay, so I am assuming this is HA and here it is HB. And similarly, these two moments are also anti-clockwise. So here we can assume HD and HC. Here actual loading 80 kilonewton is marked. So now to find HA dash, so I am marking all with the dashes because of sway analysis. Taking moment about B equal to 0 to find HA dash with a length of 6 meter. Here it is 4 meter. So HA dash into 6, which is rotating about B in this direction, and the moment is rotating in the opposite direction. MAB as well as MBA are rotating opposite direction. So minus the value of the moment is 25.66. Here it is 19.132. Here MCD is 24.34, MDC is 39.169. So HA dash into 6 minus 19.132 minus 25.66 equal to 0. From this, HA dash equal to 7.45 kilonewton. And from this side, moment about C equal to 0, HD dash into 4 minus 39.169 minus 24.34 equal to 0, where HD dash equal to 15.87. So both HA dash and HD dash is acting towards left side. So the sway load will act towards right side because the reaction we got is towards left side. The reaction is the resisting force. So the applied force will be towards right side. The W will be towards right side. In non-sway analysis also, the 80 kilonewton load is also applied towards right side. So you have to note the similarity of the direction here. So both the HA dash HD dash is equal in direction. So we can add H dash equal to HA dash plus HD dash, which is equal to 7.45 plus 15.87, which is equal to 23.32 kilonewton. We got H equal to 80 kilonewton. So H dash is acting, H dash, the force corresponding to H dash is acting right side, and also the force corresponding to the non-sway analysis is acting towards the right side. So both the directions are equal. Now the correction factor R equal to H by H dash equal to 80 by 23.32, which is equal to 3.43. So we need this to multiply the non-sway analysis. So next, first one, I'm going to write non-sway as per the steps and sway moment. First one, member. Sway moment. You keep in mind R equal to 3.43. So you draw a line to occupy different members. Okay. Remember AB, BA, BC, CB, CD, and DC. The non-sway moments are zero. There is no load on this span, so we didn't analyze the non-sway moment. We only have the sway moment. The sway moment is minus 25.566 and minus 19.132 plus 19.595, 24.631 minus 24.34 minus 39.17. So this is sway moment. Next one, final moment. You keep the formula in mind, that is non-sway moment plus correction factor into sway moment will give the final moment. I'm not using the correct tool for the clarity, anyhow this adjust. So the correction factor is 3.43. So the first value is 20, non-sway moment is 0 plus sway moment is minus 25.66 into 3.43. That is non-sway moment is 0 plus sway moment is minus 25.566 into correction factor 3.43. So the value is minus 87.69. Here it is minus that is minus 19.132 into 3.43 equal to minus 65.62. Here plus 19.595 into 3.43 equal to 67.21. Here 24.631 into 3.43 equal to 84.48. Minus 24.34 into 3.43 minus 83.48. Minus 39.17 into 3.43 equal to minus 135.35. I am writing only for your understanding. You need not write the steps here. You can directly enter the final moment. So these are the final moment for the sway analysis of the frame. I think you understand this problem. So try to solve many more problems for the better understanding. Thank you.